Math 2, Unit 5, proving theorems about quadrilaterals. Quadrilaterals, obviously quad, 4, lateral sides. So we're going to be talking a lot about four-sided polygons. Okay? We start today, Friday, October 4th, and we will be finishing up taking our unit test on block day. For you guys, that's October 16th. Okay, any questions? All right. So let's turn the page here. I left this page blank. So we're going to kind of write down some important things here. So try and write it neatly because we're going to add to it a few things as we go through. So what I'd like you to do is kind of save this area right here. We're going to write some formulas down at the end. And let's just try and put some notes over here in this 1/4 of the paper over here, okay? Over here in this section. Okay? All right, the first thing we want to talk about is interior angles. Interior angles. So the one we worked with the last couple units was a triangle. So let's draw just a small triangle here. Okay, make it as neat as you can. Okay. All right. We're talking about the interior angles. So what do we know about the sum of the interior angles of a triangle? They're 180, right? It doesn't matter what the triangle is. Hopefully I've convinced you of that at this point in the year. I've convinced you that the sum of the interior angles of any triangle is 180. If you remember back to, I think, August, I did a little thing where I tore off the corners of a triangle and proved to you that the interior angles add up to 180. So let's just make up a number here. Let's just go, I don't know, we'll go 50, let's go 60, and 70. I know that doesn't look right because 70 probably should have been up there, but it's good enough. Those are the interior angles, right? And over here, we'll just say the interior angle sum equals 180, right? Okay, and then I do want to review the exterior angles. Okay, if you remember, an exterior angle is when we just extend the side of a polygon and we end up with this guy. So if we extended the three sides of this triangle, it would look something like this. Does that make sense? Well, when we do that, what you should realize is it doesn't matter what polygon you do that to. What if we created right here a linear pair? And what do we know about linear pairs? They're supplementary. Good job. Okay. And so if this interior angle is 70, then the exterior angle must be 110. And if this interior angle is 60, this interior angle must be 120. Okay? And over here, if this interior angle is 50, this exterior angle must be 130. Is everybody on board with that so far?
Yes.
Okay, good. All right. So let's draw one more triangle here. Let's draw a equilateral triangle as best we can. We know it's equilateral, so I'm going to put that there. Show it's equilateral. And remember, equilateral means equiangular, right? So we know it's going to be 60, 60, and 60. Is everybody good with that? Okay, well, we call this a regular triangle. Or we could even say regular polygon. Because remember, a polygon is just a multiple-sided object. So triangle, quadrilateral, pentagon, and so on, those are all just polygons. So whenever you have a polygon that all four sides are, well, all sides are equal, not just four, 4, 5, 6, if all of the sides are congruent, then it's called a regular polygon. And what I want you to realize is if all of the sides are congruent, then all of the interior angles are congruent as well. Make sense? Everybody with me so far? Okay, and then let's just go ahead and extend these sides. 60, so this must be 120. 60, 120. And of course 60, 120, right? So now we can see that the exterior angles of a regular polygon are also all congruent. Does that make sense? Because obviously if the interior angles are all congruent, the exterior angles would have to also be congruent. Make sense? Okay, because the interior angle and the exterior angle of any polygon are supplementary. So far so good? All right. So let's take a square now. I don't know, let's put it over here. And a square has 4 equal sides. And it has 4 right angles, doesn't it? So let's talk about we have the interior angle sum of a triangle is equal to 180. What's the interior angle sum of a square? What's 4 times 90? 360. So of a square, the interior angle sum equals 360. And we could do that for a regular pentagon, hexagon, heptagon, and so on. And what we realize is every time we add a side, we would end up adding 180 degrees, which means if we had a regular pentagon here, it would simply be 360 plus 180 or 540. And that gives us the interior angle sum formula. So right over here, let's write the interior angle sum Okay, so we have the interior angle sum of a polygon. We have a little formula that will help us find the interior angle sum of any polygon. It is simply n minus 2 times 180, where n equals the number of sides. So we can find the interior angle sum of any polygon. It doesn't have to be a regular polygon. If you notice here, this is an irregular triangle, and its sum is still 180, isn't it? So if we take this guy and we apply it to this triangle right here, what is 3 minus 2?
1.
1, and 1 times 180 is?
180.
180. Good. And let's take and apply it to the square. Well, 4 sides, so 4 minus 2 is 2, and 2 times 180 is 360. And that is true for any quadrilateral, and in fact this formula will work for any polygon. It doesn't have to be regular polygon, any polygon that'll work. So, I got this my little toy here. So right now it looks pretty much like a square. 4 right angles add up to 360, correct? But if I take this guy and I start squeezing it and pinching the sides, what's going to happen is the top and bottom angle here are going to get smaller, or sorry, are going to get bigger, and the two side angles are going to get smaller. And because the sides don't change, they have to change in the same ratio. So as I squeeze it, you guys can see that the top and bottom angles are getting bigger, the left and right angles are getting smaller. So what I'm just trying to show you is the sum of the interior angles of a quadrilateral are constant. It doesn't have to be a regular quadrilateral, it's any quadrilateral. Okay? And we'll do several of these that hopefully will convince you at the end. But the sum of the interior angles of a quadrilateral are equal to 360 degrees. Because 4 minus 2 is 2, and 2 times 180 is 360. Good enough? Okay. So, that's how you find the sum of the interior angles of any polygon right there. Okay. Now, let's take a look at our triangle here. We have a regular triangle here, and all three angles are 60 degrees, aren't they? Because in a regular polygon, the interior angles are all congruent. So, to find the sum of the interior angles of a triangle, what would we do? We would use n minus 2 times 180, correct? Which means we would go 3 minus 2 times 180, and we would get 1 times 180, and we'd get 180, wouldn't we? Now, if we knew this was a regular triangle, we know all the interior angles are congruent, correct? So we can simply take this number and divide it by 3, the number of sides, and we end up with one interior angle of a regular polygon. Does that make sense? So that's our next rule, to find one interior angle of a regular, it has to be regular in this case, to find one interior angle of a regular polygon, we can simply take the polygon sum to find the sum of the interior angles, n minus 2 times 180, and then divide it by n, the number of sides. This numerator will find the sum of the interior angles of any polygon. But if we know it's a regular polygon and all the interior angles are congruent, we can then divide it by n, the number of sides, to find one interior angle. This only works with regular polygons, because an irregular polygon, all of the interior angles could be different. Does that make sense? Let's try it over here with a square just to make sure I've convinced you. So to find the sum of the interior angles of any quadrilateral, we simply go 4 minus 2 times 180, which means 2 times 180, which means it's equal to 360 degrees. That's how we find the sum of the interior angles of any polygon. But now, if we know it's a regular polygon, like a square, we know all of the interior angles are congruent. And I haven't said this, but hopefully it's obvious that if there are 4 sides, there's got to be 4 interior angles, right? So we can simply take the sum of the interior angles and divide it by the number of sides, and we get 90 degrees. So now we can see that in a regular quadrilateral, meaning a square, the sum of the interior angles is 360, but one would be 90. And we already knew that, didn't we? Okay, so we have a formula to find the sum of the interior angles of any polygon. We have a formula to find one interior angle of any regular polygon. Remember, that only works with regular polygons. And now we're going to come up with a formula to find the sum of the exterior angles of any polygon. So let's write that. Exterior angle sum. Okay, this formula is to find the sum of the exterior angles of any polygon. Exterior angles, right? So let's go back to our triangle over here. This is an irregular polygon, and we already made up our interior angles, and we already found the exterior angles that would go with those interior angles, correct? Let's add them up. What's 110 plus 120?
230.
230. And 230 plus 130 is?
360.
360. So the sum of the exterior angles of any irregular triangle is 360. Let's check it out for a regular triangle, meaning an equilateral. 120 plus 120 plus 120 is 360. So it looks like the sum of the exterior angles of any triangle equal 360. You guys agree with that? Is everybody good? Okay, hopefully I have your full and complete and undivided attention. Let's check it out for a polygon. I'm sorry, for a quadrilateral. Let's just draw our exterior angles. All right. So, if this is 90, this guy is 90, isn't it? And 90, 90, 90, 90, and 90, 90. So the sum of the exterior angles of a quadrilateral are
360.
360. Wow. And of a regular quadrilateral, 360. And the amazing thing, it gives me chills when I think about it, the sum of the exterior angles of any polygon is simply 360 degrees. It does not matter how many sides the polygon has. It does not matter if it's regular or irregular. The sum of the exterior angles of any polygon is 360 degrees. Now, if it's a regular polygon, to find one exterior angle of a regular polygon, what do you think we do? To find one exterior angle of a regular polygon, what do you think we do? Remember, regular means they're all going to be the same. So can't we simply take the sum and divide it by the number of sides? There you go. And that is the 4 formulas you're going to need for today. All right? So let's flip it over and let's do a couple of questions together. This is your homework. Your homework is going to be to finish this worksheet, and I'm going to do half of it with you right now. All right, find the sum of the angle measures of each polygon. The sum. There are some key words you got to remember. So we know to find the sum of the interior angles, it's n minus 2 times 180. How many sides does this guy have? 1, 2, 3, 4, 5, 6, 7, 8. So it's simply 8 minus 2 times 180, which is 6 times 180, which is 1080, right? So the sum of the interior angles of an octagon are 180 degrees. You guys think you can do 2 and 3? Or do you want me to do another one with you? Okay, I'll take that as you're good. Let's go on to 4 through 6. Find the measure of 1. You guys have got to pick up on these words. 1 angle in each regular polygon. Round to the nearest tenth if necessary. Well, let's do this guy. So to find one angle, one interior angle of a regular polygon, it is n minus 2 times 180. That'll give you the sum, and then you simply divide it by the number of sides. So how many sides do we have? 1, 2, 3, 4, 5. So this is simply 5 minus 2 times 180 divided by 5. Okay, so 5 minus 2 is 3, and 3 times 180 is 540. That's the sum of the interior angles. That's the sum of the interior angles of a pentagon. And then we divide it by 5 to find one interior angle. So 540 divided by 5 is 108. So in a regular pentagon, one interior angle equals 108. And as a matter of fact, in any pentagon, the sum of the interior angles is 140. Make sense? So far, so good? All right, let's get down to the tricky geometry problems. All right, you know what I'll do for you guys? I'll do the hard one over here for you. So, first things first, what is this? 1, 2, 3, 4, 5. It's got 5 sides, correct? So that means we've got to find the sum of the interior angles, which would simply be n minus 2 times 180, or 5 minus 2 times 180, which we already know. We already did it. It's 540 degrees, isn't it? So we know the sum of the interior angles of this pentagon is 540 degrees, correct? Well, all of these guys are expressions for the interior angles. So we're going to add them up. So 4, 8, 13, 17, 21. Did I get that right? I think so. So 21x plus, let's see, 15, 30, minus 10 is 20, minus another 10 is 10, plus 5 is 15. Did I get that right? And it's got to equal 540, doesn't it? Because we already said that's the sum of the interior angles of a pentagon. Is everybody with me how I figured that out so far? Okay. Well, we'll subtract 15 from both sides. We get 21x equals, what is that, 525? Yes? Okay, we divide both sides by 21. Uh-oh, are we going to need a calculator here? X equals C. 21 goes in there twice, right? Somebody got a calculator? That's 40, 25? Okay, that's what I thought. Good. So X equals 25. How are we doing on this? Can you guys handle 7 and 8? Yeah? All right. Let's go on to 10, 11, 12. All right. Find the measure of an, that means 1, right? An exterior angle of each regular polygon. Round to the nearest 10 if necessary. All right. So let's do decagon. So we already know the sum of the exterior angles of any polygon is, come on guys, what is the sum of the exterior angles of any polygon? 360 degrees, right? But we know the exterior angles of a regular polygon are all equal. So we can simply divide by the number of sides to find out what each exterior angle equals. Remember, this only works with regular polygons. So 360 divided by 10 is simply 36 divided by 1, or 36 degrees. I'll leave 10, 11, and 12 for you to do. All right, let's turn the page. All right. So I'm going to do 13 and leave 14 and 15 for you to do. Find the value of each variable. Well, this is pretty easy. We know this is a quadrilateral. We know the sum of the interior angles of any quadrilateral is 360, right? So this is simply x plus 103 plus 93 plus 87 equals 360. Now, I don't mean you have to write that down, but I'm just trying to really point out we add up the 4 interior angles and set it equal to 360. If I remember correctly from last period, we added those up and got 242, was it? 283? I guess I'm not remembering correctly. So 283 plus x equals 360. So we subtract 283 from both sides, and we get x equals 77? Pretty sure.
Yeah.
77 degrees. So x equals 77, but you need to remember that x and y are a linear pair, so if x is 77, y must equal 103 degrees. We can put that up there, 77 degrees and 103 degrees. So far, so good? Okay. Now, here's a good one here. The measure of an exterior angle of a regular polygon is given. Find the measure of an interior angle, then find the number of sides. All right, so this is the exterior angle of a regular polygon, correct? Are you guys with me here? So, if the exterior angle is 120, what's the interior angle? Remember, they're a linear pair, so it's got to be 60 degrees. Remember, the interior angle and the exterior angle of any polygon are always a linear pair. They add up to 180. They're supplementary. But this one is a regular polygon, so it means all the interior angles are congruent and all the all the interior angles are congruent and all the exterior angles are congruent. Exterior angles are easier to work with because we know the sum is always 360. So if we want to know how many sides, we simply take 360 and divide it by 120, which equals 3. So this must be a triangle. And we know that in a regular triangle, each interior angle is 60, isn't it? Right? We already did that one. 60 plus 60 plus 60 is 180. So I'm going to leave the 17 and 18 for you guys to do. Can you handle those? All right, I want to do 19 and 20 because these are a little trickier. So this one says a regular polygon has an interior angle measure of 150. How many sides does a polygon have? So there's two ways to do this, and I'm going to show you the actually more difficult way first. So to find one interior angle of a regular polygon, we use the formula n minus 2 times 180 divided by n. And that equals, they told us, 150. So we cross multiply, and we get n minus 2 times 180 times 1, which just means we get n minus 2 times 180, and then we multiplied here, so we have to multiply here. We get n times 150 is just 150n. Does everybody understand how I came up with that? We cross multiplied. 1 times all of this equals that. N times 150 is 150n. Now I'm going to distribute that 180, and I get 180n minus 360 equals 150n. I'm going to subtract 150 from both sides, 150n, and I'm also going to add 360 to both sides. See, when I subtract 150 from this side, it goes away, and I subtract 150 from this side, I end up with 30n. When I add 360 to this side, it goes away, and when I add 360 to this side, I end up with 30n equals 360. I divide both sides by 30, and what I end up with is n equals 12. So that's how you would use that formula to solve for the number of sides. Now, if you guys are thinkers, I'm going to show you an easier way that you're going to say, well, why didn't you just show us that in the first place? Because you have to be able to think and come up with that independent step. And I had one kid, maybe more than one, at least one that showed me last period. Hopefully others of you would pick this up. Well, we know this is a regular polygon, correct? We know all the interior angles are congruent, which means all the exterior angles are congruent. Yes? Okay. Well, if the interior angle is 150, what's the exterior angle got to be? What? 30. Very good. And we already know the sum of the exterior angles are 360, right? So if we take 360 and divide it by 30, the exterior angle, what do we end up with? 12. Okay? But you have to be able to realize that, hey, 150 is related to 30, interior angle, exterior angle. And you have to remember that 360 degrees is the sum of all the exterior angles of any polygon. So you have to be able to make that little jump. Either use this formula or make that jump. It's up to you. And number 21, I think you guys should be able to do. What I would do is solve for y first, and then know that x and y are a linear pair, right? All right, the rest of the period is for you to finish this up. What you don't finish in this class is homework.